AP Calculus, evaluating the definite integral of an absolute value function. This is actually pretty easy, and I just want to make sure that you kind of know how to look at this. So what I'm going to do, if you don't mind, is I'm going to forget what we're being asked to do here. I'm just going to look at this inner function right here. I'm going to look at this absolute value of 2x minus 1, and I just want to show you what it looks like, right? If we stop and just analyze this function for a second, it's really a piecewise function from, this is 1/2 right here, from x is less than or equal to 1/2, we have this function right here, don't we? And it looks like that, right? And you can see that it has a negative slope and it passes to the point 0, 1. But once you get to 1/2, when t is greater than or equal to 1/2, you get this function right here, don't you? So they are two totally different functions, but they're it's very easy to do the transformation. So all I want to know is, where does the change happen? We're being asked to evaluate from 0 to 2. So we're going from here to here, but we see that something happens at 1/2. So this is what I'm wondering if you can see. I'm wondering if you can see that what we have really is the definite integral from 0 to 1/2 of the opposite of 2x minus 1, right? This line right here, if you can stay with me on this line right here. Here's this line right here. And this line right here is that line 2x plus 1. I'm sorry, negative 2x plus 1. Has a negative slope, and it passes through the point 0, 1, doesn't it? So for the first part of our journey, for the first part of the area that we're going to capture, which happens to be in here, we're looking at this particular function. It goes from 0 to 1/2. And that's what I'm suggesting to you, because you have to look at it that way. We're allowed to integrate this. We're allowed to partition it out. So right now, I know that I have to integrate or find the area from here to here. I'm going to find this part first. So that's done here. Then I have to add the area of the other part, and the other part has to start where the first part ended. So the first part ended at 1/2, and it does. And it goes all the way out to 2, doesn't it? Now I'm looking at this part, right? I'm looking at this stuff in here. And that can be showed to us really easily as 2x, isn't it? 2x minus 1. So it's 2x minus 1. I need to put a dx here. Sorry, you guys. Somebody caught that. Dx, right? That's good notation. I have this whole thing covered. Now I have my integration starts at 0, ends over here, and it's continuous because it stops at 1/2, but then starts again at 1/2. So I have everything now. So this is what I'm going to do now. I'm going to simplify this. So I'm going to go ahead and simplify. Simplify this out a little bit. You're definitely going to see one of these on the AP exam. And when you do, just when you see it and go, oh, you know what, this is what Charlie was talking about. And I think that once you get that, it'll be really easy to put together. So let's just take a quick look. So I'm going to go ahead. Remember that we're going to be using the fundamental theorem of calculus, which says that the area is f of b minus f of a. And you're going to want to mention that on your exam if it's on the free response part. So I'm going to go ahead and I'm going to simplify this thing out a little bit, and this is I'm just going to rewrite this one time for you to show you what I would actually do, but is of negative 2x plus 1 dx plus the area from 1/2 to 2, because that's the interval we have to cover, isn't it? Of 2x minus 1 dx, right? So hopefully you can see that we have two fundamental theorems of calculus working. We have to do both of these things. We have to, right? We have to do f of 1/2, right? We have to do, after we integrate. Let me integrate. Let's integrate first. So let's go ahead and integrate. Let me get ahead of myself. Sorry. Go ahead and integrate here. And when we integrate this, we're going to get negative x squared plus x. If you're not sure how we got that, right? We increment the exponential value here, so it was x to the first, so plus 1, and 1 plus 1 is 2, so this turns to 2, but you also put over 2, and negative 2 over 2 is negative 1, and the same thing happens here. This is x to the 0, so x to the 0 plus 1 is x to the first, yeah? If this is not making sense to you, please watch my video on basic integration rules, and I think you'll get really, really good at it, right? And then remember, we have to show them our evaluative notation here. It says we're going to evaluate this from 0 to 1/2, and then we're going to evaluate the other part. And when I integrate this, we get x squared minus x, don't we? And I guess most people would put these brackets out on both sides. I usually don't. they're really important to have on the right-hand side because they're evaluative. And I'm going to put from 1/2 to 2, which just tells your reader what area you're capturing. And you're saying, I want to capture the area from 0 to 1/2 here, and I'm going to capture the area from 1/2 to 2 for the total interval there. So I'm going to do I'm going to do f of 1/2 minus big F of 0 here, which works out really cleanly. I think it ends up looking like negative, the opposite of 1/2, right? Because I'm using this value, I'm plugging it into here, squared plus 1/2, right? Right, and that's f of 1/2, isn't it? Minus f of 0, and f of 0, if you plug in 0 here, you get 0 back, don't you? Then let's see if you can see this. I'm going to do fundamental theorem of calculus twice. So this plus sign is this plus sign. And now I'm going to start to do fundamental theorem of calculus here. So I'm going to take, here I'm going to take big F, f of 2 here. So that would give us, right, 2 squared is 4. Negative 2, so negative 2 here, right? Minus f of 1/2. So this is fundamental. So this negative sign right here is this one right here. And f of 1/2. F of 1/2 is 1/4 minus 1/2. I'm just plugging these values in. So if I go through and do all this math, I'm going to get negative 1/4 plus 1/2 minus 0 plus 4 minus 2 is 2. This turns out to be negative 1/4, so plus 1/4 here, isn't it? And 2, I can put this all into the form of fourths, so 1/2 is the same as 2/4. I'm just cleaning my arithmetic up a little bit. 2 is the same as 8/2, 8/4, isn't it? So everything is in the form of that. So we have negative 1/4 plus 1/4, and we have 8/4 plus 2/4 equals 10/4, which is a good enough answer, but a better answer would be 5/2 is my answer. And I'm definitely going to go back and show you that if this was a free response question, you want them to see you evaluating this by part because you have an issue. So this break right here, if you were asking where do you come up with a 1/2, the 1/2 is where this function goes to 0, right? Where is 2x minus 1 equal to 0? And 2x minus 1 is equal to 0 at x is equal to 1/2. So that's how I knew that this was the spot that we were going to break it at. I hope this is helpful. It's not really, really hard. It's just weird. And it's really a pain in the a bother to have to kind of look at it this way and to do all this integration and to figure out where the intervals are. But once you get good at it, you're going to feel great because you're going to see it on the AP exam. And I just want to remind you that on the AP exam, there's no time to figure it out. So I hope the video was helpful. If you haven't already subscribed, please subscribe. And your comments are always welcome. Thank you.